Well, after studying a lot about differentiation, we'll discuss here some questions which has some specialty. Like this is a question where we are given sine of y is equal to x times of sine a plus y. And we have to prove that the derivative of y with respect to x is sine square a plus y upon sine a. Here you can see this is the function of y only. That means there is no x here. Also from the question, it is very clear that y cannot be explicitly expressed in terms of x. So what we will do here is we will just find x in terms of y. That means we will divide both the sides by sine a plus y, or we will find the value of x. That will be sine of y upon sine of a plus y. Now in most of the questions we have differentiated the function with respect to x, but here on differentiating both the sides with respect to y, what we get? We are to differentiate it with respect to y, so the derivative of x with respect to y, and here quotient rule will be applied. So the square of denominator, that is sine square a plus y. Now sine of a plus y, same, into derivative of sine y with respect to y. I am writing here derivative of minus, this time sine y remains same, and the derivative of sine a plus y, sine of a plus y. Okay. Now we differentiate. So the denominator will be same. This is simply sine square a plus y. Now sine of a plus y multiplied by the derivative of sine y with respect to y. The variable is y. So the derivative of sine y is simply cos y into dy by dy is 1, minus sine y same. The derivative of sine a plus y is cos of a plus y into derivative of a plus y with respect to y actually. So 0 plus 1. So that will into 1. That will make no difference. So now the numerator can be seen as a standard formula. See what? Sine of a cos b, sine a cos b minus cos a. I am writing this term first. Cos a sine b. I hope you remember the formula. Sine a cos b minus cos a sine b. So this is simply sine a cos b. I am writing the formula here. Sine a cos b minus cos a sine b is nothing but sine of a minus b. So our derivative of x with respect to y, the derivative of x with respect to y becomes sine of a plus sine a cos sine of a minus b. A here is a plus y minus, this is a sine a cos b minus cos a sine b. This is b. B is y minus y. Alright, so this y will be cancelled out. So this will give us dx by dy is equal to sine of a divided by the square of sine a plus y. But we are interested to find dy by dx. So by chain rule we know that dy by dx, derivative of y with respect to x into derivative of x with respect to y will give us 1. And from here we can say the derivative of y with respect to x is reciprocal of derivative of x with respect to y. So now we'll put the value of this. Derivative of y with respect to x is equal to, putting the value from here, from equation 1, we will use the value. This will give us 1 upon sine a divided by square of sine a plus y. And that finally gives us the answer, required answer. We were to prove that derivative of y with respect to x is sine square a plus y divided by sine of a. This was to be proved. Well, the hint is simple. Actually, our answer here is very clear that we cannot express y in terms of x here. So, definitely we are going to differentiate with respect to y. Will express x in terms of y and will differentiate with respect to y. And here also it can be observed that the answer is in terms of y. Well, let's take one more question. Here, this is a standard question, x times of under root y. If x times of under root 1 plus y times of under root 1 plus x is equal to 0, where x is not equal to y, then prove that derivative of y with respect to x is equal to minus 1 upon 1 plus x squared. Here, it can be seen that the answer is in terms of x only. Let's try to simplify the given expression. See, x times of under root 1 plus y is equal to negative. If we transpose this term to right hand side, what we get? Y times of under root 1 plus x. On squaring, what we get? X squared times of 1 plus y is equal to, the square of negative is plus, y squared times of 1 plus x. Now, you open the bracket, what we get is x square plus x square y is equal to y square plus x times of y square. We transpose the terms to left hand side. This gives us x square minus y square. This y square is placed here, and plus x square y minus, this will be taken to left, xy square. Okay. If we try to factorize this, what we get is x plus y into x minus y, a square minus b square. And what can be taken common here is simply xy. So it will give us x minus y. So now, what we do is simply x minus y we can see common from both the terms, from this term and from this term. We will take x minus y common. So here we get x plus y plus xy. If I take x minus y common from here, I get xy. Okay. Now, since x minus y is not equal to 0 and the product of these two factors is 0, that means this factor must be 0. It is given in the question that x minus y is not equal to 0, that is x is not equal to y. So this factor must be 0, that is x plus y plus xy is equal to 0. From here, we will simply find the value of y in terms of x, because we have to give the answer in terms of x only. So we keep all the terms containing y on the left hand side. So y plus xy is equal to minus x. Now we'll take y common. This will give us 1 plus x is equal to minus times of x. So y is simply negative times of x upon 1 plus x. Now on differentiating with respect to x. On differentiating with respect to x, what we get? Simply, if we try to differentiate it by quotient rule, simply derivative of y with respect to x, negative sign is here, keep it here. Now this is the square of denominator. Now 1 plus x, denominator same into derivative of x, minus x same into derivative of denominator is 0 plus 1. And that is our final answer. If we solve the numerator, x will be cancelled out and we'll get only 1. Let me write it here. 1 plus x. If I open this bracket, 1 plus x minus this x upon 1 plus x whole square. This x will be cancelled out. Simply, the answer is derivative of y with respect to x is minus 1 times 1 upon 1 plus x square. So this is what we were to prove. We were given x into under root 1 plus y into under root 1 plus x is equal to 0, and we were to find the value where x is not equal to y, and we were to find the value of derivative of y with respect to x in terms of x only. So what we did, we simplified it, we transposed it to the right hand side, squared to get it free from radical sign, and we arranged the terms x square with y square and x square y with xy square, so that we can factorize these and x minus y can be taken common. After taking x minus y common, since x is not equal to y and the product of these two factors is 0, that means if this factor is not 0, then for the product to be 0, this factor must be 0. With the help of this, we got the value of y in terms of x and just differentiated to get the answer. That's it. Well, we have this question, under root of 1 minus x square plus under root of 1 minus y square is equal to a times of x minus y, and we are to prove that dy by dx is equal to under root of 1 minus y square upon under root of 1 minus x square. Well, so how we can solve it? Simply, there are two methods. One is the very simple approach. We will treat it as an implicit function, because here y cannot be expressed in terms of x, also x cannot be expressed in terms of y. So what we will do is, we will simply differentiate both the sides with respect to x and we will find dy by dx by collecting the terms containing dy by dx. But there is an easy approach. What we do, we make some substitution, and that is simply, if I take x is equal to sine theta, if I take x as sine theta and y as sine of phi, that is theta is equal to sine inverse x and phi is sine inverse phi. So what we get is, the given equation gives, the given equation reduces to under root of 1 minus x square. Under root of 1 minus x square means 1 minus sine square theta, plus under root of 1 minus y square. 1 minus y square means 1 minus sine square phi is equal to a times of sine theta minus sine phi, because we have taken x as sine theta and y as sine phi. So now the left hand side is simply 1 minus sine square theta is cos square theta. So on taking square root, this is cos theta plus cos of phi. 1 minus sine square phi is cos square phi. The square root of cos square phi is cos phi is equal to a times of sine theta minus sine phi. Now cos c plus cos d. This will give us 2 cos c plus d by 2, that is theta plus phi by 2. Cos c minus d by 2 means theta minus phi by 2. On the right hand side, sin c minus sin d will give me 2 cos c plus d by 2. Cos theta plus phi by 2 into sin of c minus d by 2, sin theta minus phi by 2. So now we can see easily what is cancelled out. 2 is cancelled out. Sorry, not a, but 2 is cancelled out. So cos of theta plus pi by 2 and cos of theta plus pi by 2 can be cancelled. This will simply give us cos of theta minus phi by 2 is equal to a times of sine of theta minus phi by 2. We can see the argument is same, the angle is same. We divide both the sides by sine of theta minus phi by 2. So this gives us cos of theta minus phi by 2 upon sine of theta minus phi by 2 is equal to a, which is a constant. So now it can easily be seen cos upon sine is cot of theta minus phi divided by 2 is equal to a. Taking cot inverse to both the sides, what we get is, we get theta minus phi upon 2 is equal to cot inverse of a. Now, because right hand side is simply a constant, we will transpose 2 also. What we get is theta minus phi is equal to 2 times of cot inverse a, and theta is nothing but sine inverse x. Because we have taken x is equal to sine theta, so theta is equal to sine inverse x, and this is actually, not plus, minus sine inverse y is equal to 2 times of cot inverse a. Now we can easily differentiate. Just in a single step, we will get the answer. On differentiating with respect to x, we get the derivative of sine inverse x is simply 1 upon under root of 1 minus x square minus the derivative of sine inverse y with respect to x. So 1 upon under root 1 minus y square into dy by dx. The derivative of cot inverse x being a constant, cot inverse a being a constant, is simply 0. So from here, if I transpose this to right hand side, so this will give me 1 upon under root 1 minus y square times of dy by dx is equal to 1 upon under root of 1 minus x square. On multiplying both the sides by under root 1 minus y square, that is simply transposing it to the right hand side, we get the desired result, that is under root of 1 minus y square divided by under root of 1 minus x square. This we were to prove. Simply, this is an implicit function in which we cannot express x in terms of y or y in terms of x. What we did is we made a trigonometric substitution, x as sine theta and y as sine phi, that simplified the expression and that gave us sine inverse x plus sine inverse y is a constant. Sine inverse x plus sine inverse y is a constant. On differentiating, we just get the result dy by dx is equal to under root of 1 minus x square upon under root of 1 minus x square. Let's take one more question. Here, this is the question from our textbook from miscellaneous exercise asked in All India Exam 2011. We are given x is equal to tan of 1 upon a log y. Apparently, it seems tough, but it is very simple. If I try to take tan inverse of both the sides, what I get is tan inverse x is equal to 1 upon a times of log y, or simply if I transpose a to the left hand side, this gives us tan in a times of tan inverse x is equal to log y, and we differentiate both sides with respect to x, implicit function, and we have to prove this. We can see tan inverse x we are having. So now on differentiating, we get on differentiating with respect to x, we get what we get. See, a times the derivative of tan inverse x is 1 upon 1 plus x square is equal to log, the derivative of log y is 1 upon y dy by dx, right? So here, if I cross multiply it, what I get is ay is equal to 1 plus x square times of dy by dx, or simply if I take this to the left hand side, I'll find 1 plus x square times of dy by dx is equal to ay. Since we need second derivative, result in the terms of second derivative, so we differentiate again. On differentiating again, 1 plus x square same. Here the product rule will be applied. First 1 plus x square will be taken same and this will be differentiated. So derivative of dy by dx is second order derivative d2y by dx square, plus this time dy by dx same into derivative of 1 plus x square. The derivative of 1 is 0 and x square is 2x is equal to, on differentiating right hand side, a is constant, the derivative of y is dy by dx. Now taking this term to the left hand side, we get our desired result, that is 1 plus x square times of d2y by dx square, plus if I take dy by dx common from these two terms after taking this to the left hand side, this will give me 2x minus a times. This will become negative in the left hand side, minus a times of dy by dx is equal to 0. This is what we were to prove.